Welcome to qnawire.
Here we're going to calculate the value for effective set coming from the first ionization energy. In this case, we're given the value for helium. And remember that the definition for ionization energy is for going from the ground state, or for the state in which we're in, to a state in which the electron is no longer at the atom, which corresponds to n equal to infinity. So the change of energy for this type of process is going to be given by the expression over here, which is going to be our constant at 0.75 kilojoules per mole, multiplied set squared, which is going to be the charge, which 1 over n final squared minus 1 over n initial squared. Remember that for n equal infinity, 1 over infinity squared is actually go to 0. So for this type of process, the change of energy would be this constant, 0.75 kilojoules per mole, multiplied by set squared over n I squared, with a negative sign in front of it. And over here, both expressions are going to have a negative sign attached to it. Remember that the energies for the hydrogen-like atom is going to have a negative value in front. So this would be the case for an hydrogen-like atom. That is why we're using this approximation, and that is the reason why the result is going to give us a set effective. So for us, in this case, we're given that the first ionization energy is going to be equal to 2,373 kilojoules per mole, if I look at it correctly. And this should be equal to 1,312.75 kilojoules per mole multiplied by effective force squared over 1 squared. So the value for the effective charge would be equal to 2,373 over 1,312.75, and taking the square root of this value. And upon taking the square root, we're going to find 1.34449, which is the value provided to you over here. So that is why we say that the S electron coming from the helium atom is going to be shielded, and it is going to act as if it was having 1.3 positive charges instead of the 2 protons of the nucleus. A way to think about this is that we're going to have on the helium atom, we have these 2 protons, right? So we're going to have our 2 1s electrons. Sorry to use like this pictorial representation. But at the very end, what is going to happen is that one of the 1s2 electrons is going to be shielded by another electron. So the effective charge is lower than 2. This is because we have this negative charge that is surrounding also the nuclei. So with that, it would be all. Thank you very much and have a good one.